thank you for your talks, and we'll open the discussion by first asking you to comment on each other's talks, or to ask each other questions, or to disagree, to fight.
Oh, I would like to make a comment on his talk. For one thing, I want to defend a little bit the Just So stories. A little bit. Because they are entertaining. And science ought to be entertaining too. When you start out with a Just So story, and then you can verify it by additional data, then I think the Just So story is not any longer. I have a Just So story which people like to hear. For example, you know the phenomenon that women can wear the same thing every day. For example, I buy these kind of shirts, just 4 or 5, and I wear the same kind of outfit every day. But if a woman stands in the morning in front of her shrunk cupboard, she has all kinds of clothes in there, and she doesn't know what to put on. But one thing she knows, what she wore yesterday, she cannot wear today. That's a no-no. And if she were rational, she should say, well, one outfit makes me most attractive, and I should wear this every day. If that is the outfit, that is, but she changes. Now, my Just So story is, of course, males like to maximize women, and women subverse the strategy and say, look, we have a different one today. But as I say, I didn't test this hypothesis.
Well, I would say to that entertainment is fine, but science is about truth, finding the truth, and also getting rid of falsehood is also a very important part of it. And I think the problem with Just So stories is, okay, they can be entertaining, but they can also be misleading.
Oh yeah, of course.
And they can also confirm certain stereotypes.
Yeah.
For instance, I think one important factor in EP is that there are certain stereotypes in society about the role of men and women in society. And I think that's not such a good aspect of it, that if you have a Just So story about the wild, that all is because of evolutionary selection pressures in the past that said, boys will be boys, and they behave like that because of what's in their genes. That, of course, is very dangerous, because then you confirm stereotypes about men and women. But women should do this and that because that's what they were made for, and that's not good.
Yeah, I know.
And another more extreme.
I really don't find this. I mean, it might be in that Barish book, because Barish, except for his first books, he kind of really went far off and wrote all kinds of things.
Yeah, but the point I made earlier is that a lot of EP is published in very popular books, and of course it's fine that these books are popular and very, very good. But of course, you read that in the newspapers and the magazines and the BBC, and it makes so much sense to me. Oh yes, it must work like that because it makes it's just so it makes sense. And often it seems to be the case that it doesn't work like that. If the example of the speed dating, you switch one parameter around, completely different outcome.
Well, completely.
It was not
completely, but it was not the same effect again. Yes. Where I would say, well, there might be other factors involved. But I tell you another thing. I did what I did not mention. I said, grandparental care does not occur among other mammals except maybe for toothed whales. And I want to comment on the fact that it's not common descent, but convergence. Because I learned there is one bird where grandparental care does occur. And it can only be convergence for particular ecological reason, and that's a Seychelles warbler. A warbler is a Teichrohrsänger. Their grandparents help feeding or take care of the grand chicks, I think you would say, but I think the reason there is dispersal restrictions due to island conditions. But there it does occur. But otherwise, I admit from similarity to great apes, you cannot predict anything really. If
No, but that's a different story, I think. But also, I think from evolutionary history, you can't predict very much because often the predictions are wrong. I mean, so I think the male-female thing is, I think, it's a big thing. It's you know, if you confirm stereotypes by using science, that's not a good thing, I think. And you have more extreme examples. For instance, you mentioned Daly and Wilson. They did a study on infanticide and child abuse.
Several studies,
Several studies. They wrote a whole book about it. And the Cinderella effect. And the idea was that the chances of children being abused or even killed are much greater in non-biological
but the
fathers.
data haven't been confirmed.
Than a biological father. And of course, it makes evolutionary sense because you want to spend more effort on your genetic relatives and you don't bother about the non-related ones and might even be abusing them. And so it turns out that this is also something that Buller and a colleague, I think Smith or something, reanalyzed in his book. He mentions it, that if you look at the actual data, so the prevalence was like 40 times greater in non-biological parents than the biological parents.
In Buller or in Daly and Wilson?
In Daly and Wilson.
Oh, was even
And Buller reanalyzed it and it was like 6 times as much. But actually he discovered that the reporting bias in the police officers that had to report, this child's been killed, and then the police officer finds out, oh, she's living with a boyfriend, she's not married. It must have been him. And so the way they reported it, I'm putting it in a bit extreme way, but that seemed to be the case, that there was a bias, a cultural bias in the reporting, that it makes a lot of sense that it must have been him who did it. And it turns out that often it wasn't the case. And so if you use that kind of scientific evidence in court, which apparently they do in the United States, because they do all kinds of weird things in the United States. But that's a very dangerous thing, because that you can be convicted of something because of some scientific evidence shows that
stepfather,
stepfathers
are dangerous.
So that's another extreme that just those stories can be very dangerous, I think.
Yeah. But otherwise, I'd say. We evolutionary psychologists learn from zoologists that the females are where the food is, and the males are where the females are. And when we look at primates, I'm always stunned how different the mating systems in primates are. You could not look to your nearest primate and make any kind of predictions what kind of mating system we have. Mm-hmm. The gorillas have harems, the gibbons are monogamous, mm-hmm. The orangutans are live, how do you call
exploded times.
Late apart but together, we say in modern days. They only have occasional contact, and the bonobos are just very weird anyhow. And the chimps, they have something like group sex, there's a name for it, but they show completely different mating systems, although they are relatively close to us. To make predictions from there, what kind of Heiratsregel, marriage rules, no, you cannot make any predictions.
Yeah, so it's clear that there's no clear evolutionary relationship between all these different traits. You can't predict anything from it. The same, for instance, with auditory vocal learning. It occurs in songbirds, it occurs in parrots, it occurs in hummingbirds, and all those things in between, they don't have it.
Did you know
there's no clear branching off of
Did you know that
randomness is a very important
factor? That stuttering occurs in finches?
Yes, it can occur, yeah.
So this is the point to open the general discussion. Yes, please.
Michael Mahofer, computer scientist background. I'm interested in the survival of fittest rules, some specific rules for males. What makes males more attractive? Question to both of you.
What makes males more attractive?
To women.
To whom?
Is it the ability to make friends, or the ability to make money?
To make kids.
No, I would say it's the prospect of acquiring resources, whatever ecology you live in, which defines what resources are. These days, it doesn't that much depend upon how much money you earn. For example, a medical or a student of law makes the guy highly attractive for females, even though he doesn't earn much money yet. But this is our ecology. In others, it depends upon, you know, how much land you have, or what kind of privileges you have being an Adliger, or whether you are a good hunter. That is defined by the ecology or by the social, the historical situation. But this is the answer I would give. It is not any bodily criterion, as it is the same. It's not that they want knackigen Hintern, or with one exception. I found there is one bodily criteria that makes males attractive, especially right in the beginning. Later on it doesn't work. You must be as tall as Johan.
I just wanted to say that. Obviously, body length is a vital criterion for attractiveness in males. But so it's not the kind of question that I'm concerned with on a daily basis. But I would have guessed that sexual selection is a major factor in these things.
And it seems to be the reason is that at least in our society, tall people have a higher chance of climbing up the status ladder.
So I would prefer if you share your answering time 50 to 50.
Oh well.
There must be some evolutionary reason why.
No, you are over-interpreting. This is your own justice.
I'm taller than you, so I just compensate by being taller.
Your answer?
Yes, so this is not. I'm not a behavioral ecologist, so but I would say sexual selection is often a major factor in that kind of thing. That why do female songbirds prefer males with complex repertoires or something? It's a sexual selection thing. Why does the peacock female prefer males with huge tails, for instance? That's a sexual selection. So all kinds of factors can suddenly become important during the course of evolution.
Thank you.
I have a problem. There's a question for Jan. So
Johan.
the way you phrase Darwin's theory. So I mean, I think everybody teaches it the way that you say. Darwin has two major achievements. One of it is that evolution is a phylogenetic process, and that's what you said, explaining the history. I agree with this, but you said evolution has no mechanism. And Darwin's second major achievement is saying that selection is the mechanism behind evolution. I mean, there are other ones also, but for him that was the major component of evolutionary biology.
Yes.
So I'm a little bit confused because you never mentioned selection, natural selection, or
Yes.
whether this doesn't exist.
I mentioned selection pressures, as some say, but
Okay.
well, I think Darwin in many ways was maybe an evolutionary psychologist avant la lettre, I think, in many ways, and of course, that was some time ago that he had those theories. He was a genius, certainly, but I think the point here is that what you mentioned before, you mentioned ultimate and proximate mechanisms, or ultimate and proximate causes, even some people use it. And I think that's a misnomer, that there are no ultimate causes. There are only causes are always proximate. Now this is a very important point, I think. So, for instance, natural selection is not a causal factor for particular traits. So a giraffe doesn't have a long neck because there was natural selection in the past with a long neck. That's how it evolves. That's how it came about. Hang on. That's how it's my time now. That's how it came about in the course of history. That there was natural selection, there were selection pressures, and the long necks, for whatever reason, they survived, and the short necks didn't, if there were any short necks to begin with. And so, but the particular traits, they were there to begin with. There was variation. If you stick with that example, the long and the short necks. So there were short-necked individuals and long-necked, and everything in between. And natural selection caused, as it were, in the course of evolution, the long necks to survive, and the other ones disappeared. But they were all there, so there were causal factors involved to make short necks and long necks, and everything in between. The causal factors were there, and natural selection then does its work. But there's no causality there. So natural selection itself is a blind force that has to do with the variation that's there. It doesn't cause anything. So it's not a causal mechanism.
does it not play a role in evolutionary psychology? Because the heritability of these traits, like vocal learning, is so low probably that you don't have to take into account. This is my sort of suspicion.
That was my point. That if you look at these four factors, and of course Aristotle started with these different kinds of causation, and he got it wrong. I think one of the few things he got wrong. But you shouldn't confuse those four things. So function is not the same as cause. They're completely different things. They're logically distinct things. And so you can't use functional explanations to see that this is the cause of this particular behavior. So I remember a student once said that during his dissertation defense that the cause for female monkeys or something to disperse is to avoid infanticide by males or something. That's not a cause. That's the effect of it. So the cause is why they move away. So something happens in their brain or something. But, so the distinction between cause and effect is quite important, I think, and that's often mixed up. Also in EP, in my view, that you want to find causes in history, but history develops in certain mysterious ways that we don't really have a grip on, and can be all kinds of factors. Natural selection is just one factor, and people like Dawkins might think it's the only factor involved, but there are lots of other factors. And there's randomness, there's neutral evolution, there is convergence. Things just appear apparently because it makes sense, and in other species they don't appear. So and it's very difficult to get a grip on that, and it's even impossible, I think, near impossible to come up with explanations for the mechanisms of something, how the brain works, how the mind works, by looking at the history of it.
May I?
I would like to make a remark to your talk, Professor Euler, since I have the impression and mind that your notion of family is much idealized.
Oh yes,
and
I agree.
How it comes together with the so-called exact data.
Oh yes, I totally agree. That's why I showed an American picture of a family.
Yeah.
But may I correct your statement about the giraffe neck? I always thought that the neck of the giraffe has become long because of natural selection. But this has been disproven, because there is data. If that was the case, if it was by natural selection, if that was the neck of the giraffe should eat up here, where no other antelopes can get to, because that's where their most food, the most leaves are to get. But when you look at where they actually eat, they eat in shoulder height, here, not up here. So the reason is sexual selection.
Yes.
It's the bullfights. They fight with hitting their necks against each other and living so high, when they press here on their arteries, they knock them out, and that's what the females like, having bulls with big, strong necks.
So I just use it as an example.
Yeah.
This is how it might evolve, but to make the distinction between cause and function.
Yeah.
But it's true that the longer the neck is, the stronger it is, and the better you for it. Intra-sexual selection.
Yeah.
Let me come back to the notion of mechanism you just talked about. To my understanding, the evolution itself is a kind of mechanism that consists of two components. One component is the changes, which are mostly, at least in short steps from one generation to the next one, is random changes, and what the results of these random changes are put to the surrounding, and then the environment selects out of these number of different animals or different kinds you have there. So it's definitely a mechanism consisting of two components: randomness and rational selection after physical or biological laws. And the first one that comes up with new ideas, that is randomness in nature. That was how I understood the evolution theory. Is that right or is it wrong?
Well, he should answer, but I would say the word mechanism might have different meaning. The way Johan talks about mechanism, it's a different kind of meaning.
He meant something different.
Well,
Okay.
you should.
Well, yeah, the word function also has two meanings. I mean,
Yeah,
neurobiology
function
says
is
the function of the brain.
Oh
or
yeah,
something is
that's a
disappearing.
bad word too. Yes.
But I think a causal mechanism, maybe you would say, is that there's not much you can say from an evolutionary point of view about causal mechanism. What causes it? Because there's not a lot of cause in evolution. It's as you just said, it's a process of randomness. Mutations just happen, and then natural selection is also a random force that this happens to be
That's
more adapted than
That's not physical laws.
There is variation starting off with, so the variation came about in some way or another. There is variation there, and then natural selection is simply a blind force. One variant happens to be more adaptive at that particular time than another variant.
By chance, yeah.
10 years later, it might be the other way around.
Right.
There's suddenly, if we stick with the old type of explanation for the necks of the giraffe, suddenly all the high trees, the tall trees have gone away or something, so the long necks are suddenly not the flavor of the month anymore. So then selection process has changed completely. So it's all a random process. So there's not much cause there. And you could say that natural selection is the cause for the process of evolution, but that's almost like a truism.
Yeah, okay.
Just a technical question, but randomness is not fixed. The variability itself is also a result of selection. Right, so there is some cause from selection back onto variability.
Yeah, but the variability, in the end, you end up with certain traits that survive, and the process there, I think, is again, as I just described it.
Yeah, but I just wanted to mention that variability
Yes.
itself is
Okay.
not given, not God-given, but it's also adapted.
Right.
Yeah, but you get the variability not only by mutation, you get it by recombination too, and also by, I think, by developmental processes. This has been underestimated. In the
Yeah, and that's another factor altogether.
Deterministic. That's deterministic.
No, the developmental process I'm talking about is mainly non-deterministic.
Okay,
It's-
then you have always
it's chance
randomness.
events.
You have always randomness in it.
Yes.
Yeah, so you have genetic evolution, you have cultural evolution, and of course nowadays epigenetics is the big science now, where they sort of intermix that the way you're brought up determines how certain genes are being expressed, and so that's a big factor yet again to make it even more complicated.
Yeah.
So referring to epigenetics, Darwin for sure was not aware about the upcoming results on epigenetics. Do we have to rewrite Darwin's books as we progress in epigenetics?
I don't think so.
Well, I mean, Darwin's being rewritten all the time, I think. So you people have come with new Darwinism is already different from the original Darwinism, and that's a good thing that the theories change.
Well, I'm referring specifically to the variety of mechanisms we detect in passing traits from one generation to the next. It's not just genes.
Yeah, well, Mendel should also be rewritten.
Yes.
Well, of course, he has been rewritten in a big way already. But so things are biology is much more complicated than maybe we used to think 100 years ago. But that's good.
But if
I
a
think
mutation is the same thing, Mutation can be lost after 5 generations, doesn't play any role in evolution. The same might be true for epigenetic changes. They're transgenerational, but for only a few generations. So they cannot contribute to evolution. So I think you don't have to rewrite Darwin.
Thank you.
But maybe I can give an example maybe of how, I mean, I keep saying that evolution has nothing to say about mechanisms, but I also said that evolution can give you some clues about things. If you know that some particular trait evolved in a certain way, then it gives you a clue. For instance, one clue that I've been thinking about with others recently is about evolution of language. How can it be that we have language and other animals don't have language? How can that be? There's debate about it, but it seems very obvious. How is that possible? And also, how could it have evolved? In fact, it's the title of a paper I've just submitted. How could language have evolved in such a short time? Because 150,000 years ago, there probably wasn't any language whatsoever, and now we have this very interesting cognitive ability called language. How could that have happened? And then you can get some clues from evolutionary history that if it's true, if you believe people like Ian Tattersall and others, that human evolution was very rapid, and it's very recently that Homo sapiens developed all these cultural habits, etc., and symbolic use of symbolism. How can it be the case then that we have language? And that gives us perhaps a clue about what the structure of language would be. So perhaps language is not the incredibly complex thing that we used to think it is, but maybe the core principles of language syntax are actually quite simple, as Chomsky has been saying for the last 20 years. And that makes a lot of sense from an evolutionary point of view, if you really want to get clues from evolution, that something that has evolved so quickly in about 100,000 years, there's not much chance for any kind of natural selection to work on it, for it to be adaptive at all. Although, of course, once our ancestors had language, of course, that would have been a huge advantage, I would have thought. But that gives you a clue that maybe we're on the right track, or the linguists are on the right track by thinking of language as a fairly simple process of merge or whatever you want to call it, a minimalist process. And it makes a lot of evolutionary sense, perhaps, that something that evolves so quickly must be fairly simple at the core of it. So that's the way, I'm trying to make a positive statement about evolutionary psychology, that where evolutionary history can give you good clues about how things might actually work, what the mechanisms are.
Same which was religion, I think.
Thank you very much for this concluding statement about language, and thank you all for your discussion and comments. And as far as I know, there's a reception downstairs. So.